Setting up a homebrew shack is one of the most rewarding milestones in amateur radio. It's where theoretical physics meets the smell of solder. Your shack needs to be more than just a desk. It needs to be a functional laboratory. Here's a guide to organizing a workspace that balances RF performance with DIY efficiency. The workbench is your command center. The foundation of any shack is the bench. For a homebrewer, stability and safety are non-negotiable. Use a sturdy wood or composite table. Avoid metal surfaces as they can cause accidental shorts and complicate RF grounding. Install an electrostatic discharge mat with a grounding cord. This protects sensitive semiconductors from static pops. You need overhead LED shop lights for general visibility and a magnifying desk lamp for inspecting solder joints on PCBs. Of these, I have a non-conducting table or desktop for my workbench. Actually, my Radio Shack is not like that. It has a conducting metallic table only. And I have not installed an electrostatic discharge mat. I do have overhead LED lamps, but no magnifying desk lamp. But I do have a magnifying glass and an assortment of spectacles for magnification. One of my friends is using DC 12 volt soldering iron, which he says will prevent electrostatic discharge. I am thinking of that sometime later. Homebrewing power-hungry equipment like 100 watt linear HF amplifier requires more than a standard wall outlet. The big supply, a high quality 30 ampere switching power supply or linear one if you want zero noise, is essential for powering HF rigs and amplifiers. I do have both. My SMPS is rated for 350 watts 12 volts and I have a linear power supply rated for 50 watts and 12 volts. That's mainly for VHF work. Then you need a bench supply, a smaller current limited variable DC power supply 0 to 30 volts 5 ampere, which is vital for testing new circuits without blowing components if there is a short. You may remember that my VU2 EVQ design linear amplifier had a short, and I was most of the time testing it with simple 9 volt tiny battery and later on testing with a UPS 12 volt battery. Main safety: use a power strip with a dedicated master kill switch within arm's reach. This is something what we call as big switch to cut off the power supply in toto. A common mistake is treating electrical ground and RF ground as the same thing. In a homebrew shack, RF in the shack can cause equipment resets or even RF burns from your microphone. Ground bus bar: run a thick copper strap or heavy gauge wire along the back of your bench. Short leads: connect every piece of gear, tuner, amplifier, transceiver, etc. to this bar using the shortest possible leads. External ground: connect the bus bar to an external copper ground rod via a wide copper strap to minimize inductance. I do have an external ground, but I don't have that thick copper strap, and I do not have a thick copper connecting the ground externally. I am using just I think 4 square wire. So maybe I need to upgrade on that. Here are the essential test equipments which you need for your bench. For HF work, these are your eyes. Digital multimeter, checking continuity, voltages and resistance. Oscilloscope, visualizing waveforms and checking for clipping in your amplifier. I do not have this. Nano VNA, essential for tuning your dipoles or N-fed half-wave antennas. I do have one. Dummy load, a 100 watt plus 50 ohm load, so you can test your transmitter without radiating. Solder station, a temperature controlled iron, is a must for PCB work. I do have variable power soldering iron and 2 or 3 or even 4 or more soldering irons. I am yet to acquire a temperature controlled iron that is quite expensive. As you will be switching between multiple antennas, organization is key to preventing mistakes. You might connect a wrong antenna and have a high SWR, ending up damaging your final transistors in the radio. A manual 2-way or 4-way coaxial switch allows you to toggle antennas without unscrewing cables. Lightning arresters ensure your coax entries have surge protection before they reach your antenna tuner or receiver or radio. Cable labeling, this is quite important, even though it sounds simple, but labeling both ends of your coax will save you hours of troubleshooting later. I have 3 antenna cables coming into my shack and I have color coded them with insulation tapes of different colors so that I know which antenna is which. Even then, I occasionally connect the wrong antenna and try transmitting, and immediately my radio alerts me with a high SWR reading. Whenever you finish a homebrew project, never hook it straight to a high current battery like my 105Ah lithium iron phosphate battery, which has 1.38 kilowatt hours of capacity. Use a current limited bench supply first. I do not have that. I think I'll have to homebrew a bench supply, probably using the buck converter which I had purchased some time back, which can work at different voltages, and it is a small thing and not very expensive also. What I have been using is I use a small battery, that is 9-volt battery, for testing. But then I ended up shorting those batteries because when I disconnect it, sometimes the leads get shorted and I have lost 2 batteries. But those are not very expensive. If current spikes instantly when you are testing, you will immediately cut it off. With the small power supply, it won't go high and you save your transistors.